Hello everyone, this is practice exam of 2023, question 2F in Computation 2. Here we are asked to design this kind of digital chip where we have two sub-modules. So we have CCU and we have the parameterized counter, and then we have to kind of also design the circuit inside of the CCU, and we have to make also this connection here, which you can see. And yeah, this is also the last question, which has the most points, is 7 points. So it is really important that you practice this once and get really an idea how to do this once. Okay, so we start here. We have clock. This diagram is very helpful. So if you're not sure like how to connect the signals, you just have to look at how the connections are made, and it should be very straightforward. We'll see during the video. And we have for the CCU module, so for the CCU module, we have this diagram which we have to kind of also implement it. Okay, yeah, and this is a milling machine, which, yeah, the update should be on the positive edge. Okay, let's firstly start with the CCU top. Just to clarify a bit, in Verilog you have hierarchical design, which means you have usually a top module, and then the top module you have like sub modules, for example CCU, and then you have parameterized counter, and we want to kind of have this two get like spawned or like instantaneated inside of this top module. Yeah, so that you have CCU top. And yeah, that's the nice thing about Verilog. Everything is kind of modular, which makes it very, very nice when you're designing for FPGA or digital chips. We start with assigning the parameter of t value, and we are given that the t value should be set to 4. So we want to set this just 4. We don't have to specify the bits because for parameter like 8, you don't have to really specify them. Okay, and now we want to continue with creating these two sub-modules. So as I showed here, we want to now spawn these two modules and then make the connections specified here. Okay, we start with instantaneating the parameterized counter. So we take the instantaneate parameterized counter, we pass the parameters, right? So we do this kind of connection. So from the top module, you want to pass the t value down to the parameterized counter, and now you name the module. So I'm going to name it this given here parameterized counter instance, and now you open this, and now you start. We connect the clock. So here you can see how we connect the clock. We connect the reset, right? So reset. We connect the multiplier. Now when you want to connect wires inside of the module, so okay, for the inputs output we already have them given here, but what if, for example, we want to connect multiplier? What you do is you always want to create a wire, and do not instantaneate, like initialize the wire, just have it just like create multiplier, and then call this so multiplier brackets multiplier. And then when you also instantaneate the CCU, we also call it there, and like the connection then is fully made, as you'll see soon. So we connected the multiplier. Now we're going to connect the TR. So I'll just say okay, and we have the wire here for TR. So I'll say TR, and then also we're going to connect this small CF here, and we also have a wire for this small CF, which is located there. CF, okay. Yeah, and I think that's it. Yeah, we don't have any more. So we have created this module, made this module, and made all these connections. Now we want to go and instantaneate the CCU, which I'll call CCU. And in this case, we don't have to do something like this because there's no parameter to pass by. So we can just say, okay, this is CCU instance. and close it. Okay, so for CCU, we again want to connect clock reset as we did. So dot clock dot reset reset. Then we want to connect multiplier. So this is what I was referring to a bit earlier, that you just create the wire and then you just refer to the same wire, and connection between this port and this port will be automatically made. Okay, oops. That multiplier. Now we want to create TR. And now for the proceed thing. So the proceed, now how do you do this circuit? Well, we have assign proceed, and we say proceed should be assigned to a not TR. So we have here not TR, and not in Verilog is this, yeah, so it's this thing. I'm not sure how this is actually called, but this curly line. TR, so this means not TR, so we create this not gate, and CF, and you close it. So what you do with this is not TR and CF will be assigned to the proceed. So you exactly create this circuit. Okay, perfect. And yeah, this gets assigned. So now we say, now we have the output here. So now we just say proceed, proceed. And finally, the only things left are these three output wires to be connected. So we say, just gonna go copy pasting this, this, and like this. Okay, perfect. Okay, now we can see no errors here, meaning we have this correct. And now we start with the implementation here. Now this is like every other finite state machine that you've done. It's a merely finite state machine, but unlike the exercise 2D, where you would only update every transition, here it is specified in bold that it only should update on the positive edge of the clock, right? So unlike on 2D, here we should actually keep track to only update on positive edge clock, which means every register will have its sequential counterpart. Okay, so that's the difference between 2F and 2D. Okay, we now continue to create all that stuff. So we say register green walk R, green walk next. So we want to do this now for all of them. Red hand or next, and I also want to say rect TR or next, and also of course let's not forget we have 3 states, so we want at least 2 bits. State, register, next state. Okay, let's create the parameters to call the registers. Walk is 0. Oops. Quotient is 1, and hand is 2. Right. Okay, now we want to continue further down. Always create, always at pose edge clock begin, and if reset begin and else begin, and now here we want to reset all of these variables, right? So all the synchronous variables should be reset. It's only the R's. I keep calling them variables, but they're registers. Don't mix that, those two. Okay. Okay. TRR should be So the initial state of like the reset, it should be, it's given here. Okay, so it's like the first variable which goes in. So instead of keeping it this, we should change this to 1. Green walk should be 1. And multiplier should be 2 bits 0 1. Okay. And now down here, what we want to do is, yeah, we should now update with their combinatorial part. So here we say next, orange, next, red hat, next, multiplier, next, tr next, and then walk is just next state. Okay. And now we go create a combinatorial logic. And here it's just going to be, first let's make sure we don't have any latches. Right, so we're gonna do this to make sure that you always are driving the signals. Okay, and now we go, we say case, current state, and okay, now we are at walk, and we say, okay, walk begin end. If, so our variable which decides whether to jump is proceed, and all the rest are outputs which should change in transition. And that is denoted by the slash here. So if proceed, so if the proceed, yeah, begin and else begin and. If proceed is true, so if it is 1, we should go to caution. So next state should be caution. Yes. Now we want to now also kind of update. Just copy this whole thing. Place it here. Yeah, something like this. Green walk. Well, what should the green walk be? It should be 0. Oops. So that should be 0. Orange walk should be 1, and red should be 0. All denoted here. Multiplier should be 2 be 0 0, and my tr should be 1 next discussion. I copy again, copy paste this thing here. If I'm looping at the same port, so if my proceed is 0, then I want to still be at walk. I want the green walk to be 1 and the rest to be 0. Multiplier should also be 0, and tr max should be 0 here. Okay, now I'm just going to copy, paste it here, caution. Now I'm at the caution. Now if I'm 1, I have to move down. So like here, oops. And now I change my multiplier to 1 1 because it's specified. I change my tr to 1. Okay, that's already done. Red hand should be 1, play should be 0. And the next state is hand. Okay, now if I'm looping back into caution, I want tr 0 0, multiplier should be 1 1. Zero, this should be 1, so my orange will be 1, and the next state should loop back to caution. Now my orange walk also to be 1. Yeah. Okay, one more state left, and that is the hand. So if proceed is 1, we put tr1. We say multiplier is 0 1. We say that the red hand is 0. We say green is 1. Yeah, 0 1. We look back. Yeah, we should say here we're at walk. Okay. Okay, that's done. Made it sure. And if it's wrong, then we just like kind of loop back. So now we create this lost transition, and green walk next is 0, orange is 0, red is 1, multiplier should be 0, 1, TR is 0. Okay, so we have now finished our transition. Okay, and now the last thing left is just to assign the variables to the end, and that's it. Assign green walk is equal to green walk r, so synchronous, as they mention it here. Oops, sorry. Assign orange walk r, assign red hand equals to red r, assign tr assign multiplier is equal to multiplier r. Yes. Okay, so now if we run it, oh, we have just a bit of problem. Okay. Yeah, and oh, see, I've set everywhere it's 1, but it should be 2 bits. Let's make sure this is everywhere 2 bits. So for that, okay. Yeah, and we can see that we pass all the test cases. So this is just a bit more time consuming or like complicated, but necessarily if you're if you're fine with finite state machine, the only thing that addition that has is like instantaneating modules and connecting them together. So yeah, thanks for watching. I wish you best of luck on the exam. Just as a tip, no matter, always use the debugging. Try to analyze where the problem is. You have the reference. You have what you're outputting. Always try to do that. And no matter how complicated the finite state machine is, if you just go through it state by state and just like do it state by state, by the end you'll see that, oh, you've done the whole thing. So never worry about that. And yeah,